1973 Pinball Machine a computer. So old technology is very fascinating, especially also the pinball machines. And they are electromechanical, but they are still programmable. And we will have a talk from Franz Boyen about that part. He is one who's working in IT for a long time and interested in all technique. Welcome.
Thank you. Thank you. Thank you for your introduction. And is everybody can hear me? Yeah. Okay. Also in the end, thank you very much. Yeah, I'm interested in all technology. I'm fascinated by that indeed, and I like to work on classic cars. That's what I'm doing already for more than 30 years. But when I found this pinball machine, I think, well, that's a classic one too. And how does it work? And I bought one. I bought one second-hand, fairly good shape, but of course a few problems were there, and I tried to fix it. And when I tried to fix it, I thought, wow, what's in there? A lot of technology, a lot of knowledge in this machine. Where is that knowledge? What's happened to that? Because we replaced everything by digital technology, and there was no electronics in there. It's also, everything is electromechanical with relays and little motors and stuff like that. And I thought, well, this looks like it's functioning. It does do some program. There is a program in there. Is this a computer or not? And what I'm going to talk about is this machine, which is actually a Bally Monte Carlo. Bally was built in Illinois in the US. They were imported. This one was located, came from Belgium. But that's the one I have. And if you're interested to see a little bit more about that, I'm inviting you to our village because I've got the machine with me. Not here. Bit too heavy to carry it. It weighs a bit of about 125 kilograms, so that was a bit of a problem with all the mud, but we succeeded. So, is this a computer? Well, then you have to understand, of course, what a computer is. And I was checking that, and I found von Neumann, which was a person in 1943 or something like that, in the last age, in the 40s, and he defined already an architecture for a computer, and you can see the diagram over there that a computer should have an input device, an output device. That's clear. Well, we are used to screens. This one doesn't have a screen, but it does have output. It does also have a central processing unit, and it even had a memory. So I think, well, is this a computer according to von Neumann? Well, von Neumann is talking about the communication bus. I will come back to that later because, of course, this one has a bit of a different communication bus than we are used to in modern PCs, of course. But it does have a lot of similarities. So let's go through these different parts of this architecture and check whether it complies to the design that von Neumann had. And if we are looking to this schematic, then how does the control unit look like? Well, in the computer there's a lot of logic, of course. In this case it's an engine, it's a motor with programmed disks. Arithmetic is done by counters, also by disks and relays. There's even a memory in there, and I'll go through each of the steps within my presentation. Well, there's of course no keyboard or no mouse. But what's a keyboard? It's just a bunch of switches. And there are many switches in there, including tilt sensors and coin detection. We've got output, a lot of lights, score counters, kickers, also giving output, and the electronic is physically wired, of course. So, how does the output look like? Well, of course, the most obvious, as you can see on the screen on the right side, is the counters. They count decimal. It's a decimal output, and every time the 9 goes into the 0, it will raise the upper digit to 100, 1000 or 10,000. So it has a decimal output, of course. It also has a counter for credits. It has a lot of lights giving you information about what player can play, because you can have up to 4 players. It counts the balls, the gates, the bonus, the tilt sensor. All is displayed with lights within the output. Also, the kickers give you mechanical feedback when you are scoring, and you can see it on the left side where there is a very simple sound effect with 3 different tones. For the most high, the smallest one is telling you that you scored 10 points, the middle one scoring 100 points, and the lowest sound is 1000 points. So, and you see also a bell with a sound effect on scoring. So yes, it does have quite a lot of output. The input, as I told, is of course not a keyboard. Well, it starts with the coin slots. You can have up to 3 coin slots. It can detect what kind of coin you are putting in, and depending on the coins that are pre-configurable, it will give you 1 or more credits to play with. This machine does not detect coins anymore. It's hacked, and that's why I'm here, of course. So that's very fortunately for us. We don't need to pay anymore for playing these games, but these were very popular in the 80s and 90s in the bars, etc., where people were gathering around this kind of machines and playing with each other and trying to get a high score and be better than the others, of course. Also, the input, there is a lot of special switches for bonus points, for the post going up and down, so the ball cannot leave the game easily. For the tilt, if you are trying to break that machine, or maybe to disturb it. And of course, there is a switch when the ball goes out. And game controls are a bit different, as they are not really input to the machine, but you can of course play with the flippers, you can open the gates, you can shoot the ball, and that's of course very important to collect the points. How about the memory? Yes, there is a memory in there consisting of 16 bits. So there are 16 relays, and you see it on the bottom right on that photo, where there are a lot of switches that can be activated by the switches in the machine, and they will remember how many bonus points you will collect when the game, when the ball is exiting the game. So they are used for bonus points, for pattern detection also. If you got 5 evens, you get extra bonus. You got 5 odds, you also get an extra bonus. There is a special mode, so you can get an extra free game or an extra ball. I'll show you how this works with bonus points, because I made a little movie of that. That's next after this. Sorry. And of course, you need some arithmetic or some logic units, otherwise you cannot collect bonus points. So scoring is calculated by mechanical decimal counters. It detects whether you go from 9 to 0, and it will automatically trigger the next figure, so you get a higher score on that. There are also discs being used, and you see that on the right side on the photo. They have, it's a bit difficult to see, but the discs have little notches, so it will trigger the switch, and there are discs that will trigger 5 5 pulses to collect 500 points or 5000 points, depending on which switch is activated. I told you about logic functions. In the middle you see a ball. If you are trying to lift very carefully, so the ball will go back into the game, that little ball will activate the switch and the game is ended. On the bottom left you see a little swing. If you shake it, it will detect and it will end the game. There was a detection mechanism, of course, to detect coins. Well, people tried to get a free game by slamming the door where the mechanism in there, and then you get a free game. Not anymore, because there's a tilt switch behind the door, so you don't get a free game. The machine is blocked. And of course, there is a logic function that the game is ending. Well, game ending, maybe I should say, when the ball is exiting the game. You have 5 balls, or depending on the configuration, but it will detect that the ball is out of the game, and it will start collecting the bonus points and starting the next game for the next player or the next ball. So there's quite a lot of logic in this machine, and it does do some kind of arithmetic. that shows us how many points you are collecting. Let's see how this works when it adds bonus points. So this is the mechanism that's being activated by the ball exiting the field. We tested this, there's some sound in there, and let's see if it works. What it did at this moment, and I will play it again. Each half cycle is 5 pulses. So to collect 5,000 points at the end, it will do half a cycle. In this case, I had 20,000 bonus points for this little movie. And let's see, you can count with me. You get 4 times 5 pulses, 4 times 5,000 points. So, that's 20,000 bonus points. That's the maximum you can get in bonus points. And that's how it's activated. This can also be activated by switches on the board, because there is also some switches that will give you 500 points, depending on which switch. The same mechanism is used to give 5 pulses to the counters, whether it's 500 or 5,000 points. That's why there are so many contacts. It depends on which relay is activated, where the pulses go to, whether they go to the 100 counter or to the 1000 counter. Of course, after collecting the bonus points, the memory has to be reset. So that's the next phase when the machine is running. And resetting the memory is done with this bank. This is the memory bank. If you can count quickly, you will see 16 relays remembering the settings, not just the bonus points from from 0 to 9, yes, so 10 times, but also whether you have all odds, all evens, special mode, stuff like that is remembered within this machine. And it's reset by an engine with also notches that will reset the memory, and you will see that happening now. Let me see. Does it work? No, one moment. So you see a full turn of the engine, and if you watch carefully, I'll show it again, you will see that the relays are released. This, one moment. You see them all going up. All the contacts are released. So now the game has ended for this ball, and another ball is entered into the game, and you can start over again, depending on how it's configured and how many balls you get. There are also, well, of course it's not programmable, but it is programmed, I think. I mean, it's fully hardware based, but somebody designed this system, designed a kind of program, designed the logic, and built this into the hardware, into the wiring of this. They also built in some configuration options, which I think is very keen. They thought about it. You have a configuration option where you can choose with a little connector whether you get 3 balls or 5 balls per game. The coin game ratio. There are configuration that for the first coin, the first coin slot, you can configure it whether you get whether you need 1 or 2 coins for a game, depending on, of course, international value of your where to place this machine. So that's a configuration option. You can also configure whether you can get 1 or 2 games for a coin. And the third slot, you can even configure it up to 6 games per coin. So if you have got a large value, a high value coin, you can get multiple games for 1 coin. And you can get free games. On the bottom left, you can see how to configure the wires for the high score, how to set it for getting a free game, and you can set it into the 10,000s and into the 1,000s. At the moment it's configured for 88,000 points, and for 88,000 points you get a free game. Of course it's useless nowadays because you don't need to put in coins, but it's amazing how they configure that. This also means that the machine is able to read your score. It can read the decimal counters, what is your score? So it will detect the 88,000 and that will result in a free game. That's beautiful how this was designed and how this works. Of course, there was a lot of electronics in there, not electronics by digital, but all electromechanical, as you can see on the upper right corner, if you have a look inside. And that's not all, there's more even. So, von Neumann was talking about the bottleneck between the memory unit and the central processing unit, and you probably aware of that bottleneck when you are working with a computer system, and this still is there, that bottleneck, but it is absent in this machine. You know about the von Neumann bottleneck? So where, yeah? Somebody who doesn't know? Yeah? Well, the von Neumann bottleneck, you know, you can explain? No, okay, I'll do it. I'm sorry. Yeah, the von Neumann bottleneck means that within the communication between the memory and the central processing unit, you can only transport data or program, but not together. So, first, of course, you can get program from memory, but you cannot get program and data through that bus simultaneously. So it's either program code or data. And that means it's a bottleneck. It's not in this machine because everything is hard-coded. Everything is hard-wired. Every switch has its dedicated wire. So that's, I think, an advantage for a machine like this, that there is not really a bottleneck in this one. It's parallel mechanical processing with dedicated units that are pre-programmed, of course, which are configurable. And you see here some of those how do you say that, rotating contacts that will receive pulses and they will say, okay, now the next ball or now the next player, or it will also count the coins or count the balls that are in the game. So they are dedicated units being programmed. So it's not a long presentation, but is it a computer? Well, sort of. There is a logic unit. We've seen that. It does do a lot of logic. So there is a logic unit. There is a memory in there. It's small, but it's there, 16-bit. There's I/O, and it is programmed. However, it's in the hardware. It's also configurable. So if I look at the schematic of von Neumann, yes, there's a lot of similarities. However, no software, of course, no digital I/O, CPU or whatever. But is that really required to be a computer? Well, we don't know anything else anymore. I mean, we are used to that. But if we look into the history, for example, to the 1946 ENIAC, one of the first programmable computers, does anybody know how this machine was programmed? Patching wires. You can see here the wires. So it was all programmed by patching wires, the same like the pinball machine. However, in the pinball machine they are soldered. It's a bit difficult to change. Here it's patched. So yes, I think it has a lot of similarities with the early computer systems. It's a kind of mechanical computing. Not as good as the ENIAC, because that was, I think, pretty more programmable than this machine. But somebody thought about this, how to build this. So yes, I think it has a lot of similarities. But you can decide for yourself what you think about this. Is this a machine, a computer or not? Well, if you want to know more about this, I'm happy to take some questions. But also, if you want to see the machine, I'm inviting you to our village. We are back to the 80s party. This machine is from the 70s. Well, in the 80s it was played a lot also. We are in the pink area. You are very welcome to play a game or to see something more about how it's functioning, how it's built, and be amazed, like I was amazed the first time I was opening this machine, and see how it worked. So thank you for your attention.
Thank you. You want to have some questions?
I've got one.
that's the engine is operated indeed, and it gives 5 pulses. So then, and then through the relays, it goes either to the 100 counter or the 1000 counter, depending on the state of the game. Yes, yeah, yeah. And then, if you really want to know how it works, you can check the schematics, if you like, and so yeah. And then you can find out yourself, hopefully. Good luck. Everything is very nice documented, but it takes a little bit of time to understand it. One of the things I found very amazing when looking at the schematics, I thought, it's all condensators. Is that all condensate? No, it's an open switch. Oh, that's a different symbol. I was not used to that, but okay. But yes, it's very nicely documented. This? Yeah. It is a bit yellow, isn't it? No? It's old, yeah. You see the difference in color now? Oh, I don't know. I think this is original, I'm not sure. I don't know. The machine is from 1973. This is the original documentation. Oh, over there, sorry. Yep.
Hi, thanks for your talk. I've got another question. I was just wondering, in the multiplayer game, then the machine has to remember the score of player 1 when player 2 is active. So there must be more memory than just the 16 bits, right?
Yeah, but it's only for one ball that it remembers the bonus. So after each ball, it will count the bonus points. So for the second ball, it starts over again with 0 bonus, and you collect bonus again. And you see there are 4 counters over there, 1, 2, 3, 4, for 4 players. So actually it doesn't really remember 4 players. We understand that this is for player 2, 3 and 4. Yeah? Okay, thank you.
Very interesting talk, thank you. So can you comment on maybe one of the things that were wrong with the machine and sort of your journey of figuring out, like, how long did it take you to fix that?
Well, one of the big issues can be, of course, dirty contacts. That's something you have to be very careful with the contacts, because these machines are designed for heavy operation. But the contacts can get dirty, of course, especially if the machine is not used very often. Then you have to be very careful of cleaning it. So that's something I had to check, at least for some of the items. Why is that a difficult issue? The contacts are protected by iridium. That's what I've understood. And iridium takes care that it doesn't rust or whatever, or doesn't oxidize. But the relays are designed that the contacts, when closing, are moving a little bit. So you get a little bit of this. So they are self-cleaning. But when they get dirty, it might be a problem. So you should never clean the contacts with abrasive paper or sandpaper or something like that. Use something soft. So that was something I had to do for some of the functions. And another thing was maybe a simple one, but I had a problem that the fuse of the lights was blown. And all the lights are in parallel in 6 volt. So where is then the problem? And that was quite a journey to find out the one light, and it didn't blow the fuse always, but it did have a little bit of a problem. Playing the machine, after 10 minutes it was of course moving, and then suddenly the fuse blew out and I had no light anymore. But I found it and I fixed it, and now the fuses are lasting quite long now, so yeah. No,
How did you convert it to free play? Like a button for a coin? Or?
Yeah, it is a button now which is giving you 1 free play actively, but you can push it as much as you like for 4 players. So yes, it is instead of the coin detection. So that's rather simple. Yeah.
And is there an option to build some logic that when it detects there are no plays left, you automatically add one, so you don't have to push the button?
Yeah, but you always have to start the game by there on the front side. There is a button, so there is a counter in there for credits that goes up to 25 credits. It's still in function, but it's bypassed. But if you get free plays, then the counter will add up to 25, and you can use those credits still for playing. Yes.
That's cool.
Yeah. over there. One moment, you get a microphone.
Thank you very much for the presentation. Very interesting. Have you done any other machines like the old one-armed bandits and such like?
Not yet.
Oh, cool.
Might be a new challenge. Yeah.
They're
Okay.
excellent, aren't they? Lovely machines. Thank you.
They are. I think so too. Thank you. Okay. Oh, one more. Yeah.
Talking about coins, do you know how they manage different coins in different countries? Because you said it was built in the USA, and I'm guessing in Belgium they had different coins in different sizes. Do you know how they manage that?
That's true, because the slot where to put it in has different sizes. So that's the first detecting that big coins don't fit in, or small coins, whatever. But small coins, of course, will fit in if the slot is. Then behind that, there was a mechanism that was weighing the count. So it was based on weight only, so the size and the weight. So putting in a small coin in a big slot would not trigger the weighing mechanism and would not trigger any free play. So that's the only thing. And you can have 3 of those mechanisms behind it for 3 different types of coins. And that was, of course, and you can adjust that mechanism on the weight of the coin, and that's how it was being configured for each country. Yeah.
Clever.
I've got a tip for people who own a machine like that. Mostly they play only the first player, but it's very bad for the context for the second, the third, and the fourth player. So when you own a machine and you play it, please play 4 players because otherwise the context will rust.
Yeah, well, they will get washed or dirty or whatever, and it's very good. The machine is being used. I agree with you. So use all 4 players. I agree. Yeah, very good. Thank you.
So thank you, Front.
You're welcome, and you're welcome in my village if you want to see it and play it.